This is my Bluetooth programmer written in Visual Basic 6, and you can see it has a bunch of different things we can do. We can set the mode to command mode or data mode. We can set the name of the Bluetooth module. We can set the password. We can set the baud rates that we're talking to everything, and we can set the USB serial port for this PC that's going to be used to talk to this thing, and we can open and close the serial port. So if we hit get name, it sends this AT command to the Bluetooth module, and it returns the name, which is HC05 in this case. Now if we want to set the name, suppose we want to set it to Crown Tools, which is my helmet, Bluetooth helmet sensor module. We can set that, and then we can read it back to see if it got set, and there it is. It got Crown Tools. So if I look at my Bluetooth devices that are discoverable, it would find Crown Tools as a potential Bluetooth to pair with. And I can reset the password if I want to. Right now it's just set to 1234, which is the default. But the main thing I want to do is make sure that I can change these names, because I have so many of these HC05s modules that it gets very confusing when you see a bunch of them listed when you're trying to pair with a particular one. Okay, so that's really a brief introduction. I can set it to data mode and then actually send data to a remote device via Bluetooth, or receive data from a remote source. But that's all I wanted to do right now, is just a brief introduction to this Visual Basic program and show that it actually works. This is what the actual programmer looks like when I do a get name. Little flash of light, and that's it. Here's a get password. Here's what it looks like when I try to pair to it using a Bluetooth from my smartphone. So it lights up to tell you that it's paired. So we can operate this as a Bluetooth transceiver, or I can use this module for programming. So it's a complete test system. So if I put it into command mode, it should drop that connection. And it does. Next up, I'll try the 5-volt programmer. Okay, here I'm going to set the name of my GPS clock, because it's always on and I don't want it confused with anything else. So GPS clock, and set that, and then we can just read it back to see if it made it, and it did. So that now when I see the names of Bluetooth devices, this is going to show up as GPS clock. This one is a 5-volt module, so it needs my second programmer. This is the other module, which uses these 5-volt HC05 devices, which have a header on them, and you can see it's waiting to be paired there, and this is what it looks like when it's being paired. So it changes the flashing rate. So now that's paired to an external smartphone. But this is the same sort of thing, except this This Arduino is running at 5 volts, whereas the previous one was running at 3.3 volts. And it can interface to this 5 volt module. This is my smartphone showing several of the Bluetooth modules that are available for pairing, including the Crown Tools and GPS clock that we just programmed. The Crown Tools was programmed with the 3.3 volt castellated programming module, and the GPS clock was programmed with the 5 volt header programming module. Okay, these are the two Bluetooth programming modules. One can handle 5 volt modules with the header, and the other one can handle the HC05 that just has the castellated pinouts on the edge. And the way I do that on the castellated one is with these fancy pins, which are just spring-loaded to fit into the notches in the castellated edge. So I had ordered some expensive flexi pins to do this, but I promptly squirreled them away somewhere where I couldn't find them. And what I ended up with is just using these test points. So the way that works is on the circuit board, I don't know if we can see this, but the pads here have two holes, two vias for each pad, which allows me to put in these test points. So the little test point has a little hoop, and these little beads can be removed, leaving just a little hoop with two pins, and that gets inserted into these pads that have two holes like this. And I just solder one of the pins, and it allows the rest of it to be spring loaded so that it makes good contact with the notches in a castellated pinout. And you get things like Raspberry Pi Picos that have that form factor, so if you need to make contact, these things are really cheap. There's a whole box here, I don't know, 50 or more in there, and they cost a couple of dollars for the whole box, so they're really cheap compared with pins that are made to do this. So that was a good find and a really good way to implement a removable system where I don't have to solder the module in just to get it programmed, and I don't have to have a custom program in each system where I put in one of these modules, because we don't want the thing to be reprogrammed every time you turn the power on, so it would have to be a special program that's run once and then you reprogram it to do something else. In this way I can just program them before they go into the application, and then they're fixed. So, long explanation, but that's really been on my bucket list for a long time, to find a way to make connections to these devices without soldering. I bought a bunch of pogo pins and tried to figure out a way to use those, but this is way better. It's easy to get the cards in and out, and they make great contact.